All right, today we want to look at the area and perimeter of triangles. Now, we're going to start with not a triangle. We're actually going to start with a rectangle. And remember, rectangles are actually a special type of parallelogram. They have 4 sides, 2 sets of parallel sides. But why we're starting with a rectangle is because we've already established that the area of a rectangle is basically its base times its height. And we're going to want to use those terms. In the past, and even in class, I've talked about length and width. Well, we're not going to necessarily do that here. We're going to look at base and height. So, area of a rectangle is base times height, b times h. Now, if I were to take and I were to cut this rectangle in half, I would have a triangle. And the area of this red triangle, this shaded triangle that I am kind of putting these red slanted lines in, the area of that would be exactly half of the rectangle that we had before. So the area of I'm just going to put the triangle here. I'm going to just put it in red. Okay. Is going to be equal to half the base times the height, because it would be half of the total area of the rectangle. So we put this half out front like this. And what's nice about this is we can use the same base and the same height, but once those are multiplied, we just cut that value in half, and now we have the area of the triangle. So this could really be any triangle. I could say that, okay, this is going to be a triangle with a base equal to 5 and a height equal to, let's say, 3. Okay, so if I want to know what that triangle is, I would just say, okay, that would be 1/2 5 times 3. I always recommend multiplying your bases and heights first, so I'm going to take half of 15, and that's going to give me 7.5 units squared. Again, remember, when we're dealing with area, we've got to square our units. So even though there's this half in here and we've modified some things, it's still units squared. Okay? Now, what's really neat is that this then works for any triangle, because a triangle is always going to be half of a quadrilateral. I'll give you an example here. Let's cut a bunch of quadrilaterals up. Okay? And actually, to do this, we're going to go back to some previous notes. Let's just take a look at these quadrilaterals that I drew in a previous set of notes. I'm going to go ahead and copy all of these quadrilaterals, and I'm going to bring them into my triangle notes for today, like so. All right. If I wanted to, I could cut all of these in half. So I could cut this in half, this parallelogram at the top. You'll see I have a triangle. I can cut this rectangle in half here, and you'll see that I now have a triangle. I can cut this square in half down here, and you'll see that I now have a triangle. I can cut this rhombus in half. And you'll see I have a triangle. And so, because the area of all of these quadrilaterals is base times height base times height, base times height, base times height. Because all of them are base times height, the triangle formula, the area of a triangle, is always half the base times the height. So this is the formula we're going to be using today. And half the battle sometimes is just figuring out what's the base and what's the height. So let's look at several examples of triangles. If I'm dealing with an isosceles triangle, so if I'm dealing with a triangle like this, okay, my base can be this side here, but my height is going to be from that third point, where that blue dot is, straight down so that it forms a perpendicular with the base. So that is going to be my height. And that's really important for our discussion about triangles. Once you've established your base, so let's say here's your base, your height has to be a line that forms a perpendicular with that base. It could even form a perpendicular with, like, out here, which would be like still perpendicular to the base if you imagine that the base went on forever in any direction. So the height and the base have to form this perpendicular relationship when it comes to triangles. So what it will never be, if I'm just going to draw this quickly, if this is my base, my height will never be one of the sides on a triangle, unless that side forms a perpendicular with the base. Okay, so let's take a look at some examples. Let's say that I have a triangle that looks like this. Okay, if this is the triangle I'm working with, my base could be here, but my height is going to be out here. It's going to form that perpendicular with the base. So I would measure this distance out here. And in most problems, like the ones in your book, and you'll see this in, like, on page 385 in your text, okay, you're going to see examples of triangles that are doing this. They're forming this perpendicular connection that's outside of the triangle. All right, there are some triangles that are easy to work with, like the right triangle, for instance. A right triangle has a relationship that looks something like this. Okay, if I go ahead and were to complete this. Okay, a right triangle has a right angle. And so if I make this bottom side my base, then the other side of the triangle does end up being my height because they have this perpendicular relationship. I can also have triangles like the one that I just previously drawn up here, right here, where the height can be measured inside the triangle. And this oftentimes is when you're dealing with acute triangles. So here's an acute scalene, and let's say that this bottom part is my base. Then my height can be measured here, like so. So there are definitely different ways in which we can measure the base and height of different types of triangles. Now, once we know the base and height of these triangles, calculating their area doesn't become that great of a challenge. So, area equals 1/2 base times height. I'm going to copy this formula down so I get some practice with it. All right, and I'm going to put some numbers on the board here so that we can practice measuring the area here. I'm going to say that the height of this particular triangle over here is 2, and the base is 3. I'm going to say that the height of this middle triangle is a 3, and the base is 4. And then down here at the bottom, I'm going to say that this height is 11, and the base is 13. And we're going to go ahead and just calculate these. Let me focus on this one first. Area equals 1/2 3 times 2, which equals 1/2 6, which equals 3 units squared. So the area inside here is 3 units squared inside of this triangle. All right, now I have this triangle. I have 1/2 4 times 3. Now 4 times 3 is 12. So I have 1/2 of 12. That's what I'm working with. And 1/2 of 12 is 6. So this has 6 units squared as its area. And then down here, I have 1/2, the base, which I've made a larger value of 13. Notice you can put parentheses around values. I'm color coding mine. Height of 11. So in this particular problem here, let me just go ahead and switch. Okay, equals 1/2. Now 13 times 11. Well, 13 times 10 is 130. Okay. Add another 13, and you get 143. All right, so we're going to go ahead and do the math here. I'm going to just copy this down. And I'm going to put this in parentheses like so because I don't want it to get confused with the multiplication that has to happen here. There's got to be some multiplication. Now, 1/2 of 143 is going to give us a decimal. Okay? If you take 140 and divide it by 2, you get 70. And then 3 divided by 2 is 1.5. And so you should end up with 71.5 as your answer. All right. And so that's how you use the area of a triangle. Now, perimeter of triangle is just adding up all the sides of a triangle. So if you're working with triangles and you just need to find their perimeter, okay, don't want to move that triangle. Let's say that I want to know the perimeter of this triangle, okay, I just add up all the sides. So if I had a triangle that was 3 and 4, like so, where I had 3, 4, happens to be 5 over here, I would just add 3 plus 4 plus 5, which is 12, all right, in order to get the perimeter of that particular shape. So again, perimeter is not that hard. You're just adding up all of the sides. Area is the one that you've got to do a little bit more practice with because you've got to practice using this formula. Okay. The two area formulas you will be required to memorize in my class are going to be the area of rectangle, so base times height, parallelogram, and then the area of a triangle, 1/2 the base times the height.